everyone, welcome back to my channel. So for today we're going to talk about first order circuits, and I have here a quotation: keep the faith, the most amazing things in life tend to happen right at the moment you're about to give up hope. So our discussion for today is related with the capacitors and inductors, so I hope you have already watched my previous video about this. And if not, you can actually check out my channel to see the capacitors and inductors. So let's start with the source-free RC circuit. So when we say first-order circuit, it is characterized by first-order differential equation. So example of that are RC and RL circuit. So source-free RC circuit occurs when its DC source is suddenly disconnected, and a circuit response is the manner in which the circuit reacts to an excitation. So we have here the source-free RC circuit. The energy already stored in the capacitor is released to the resistors. Now let us consider this circuit. So we have here the flow of the current IC and the flow of the current IR. So by KCL, you can say that this is IC plus IR is equal to 0. And from our previous video, we know that our IC is equal to C dV dt. Okay? And our IR, of course, from our circuit, we have V and R. And by Ohm's law, IR is just simply V over R. Let's just equate it to 0. So we'll have to manipulate these variables so that the dV and V is together. So let's just put it here, dV over V, and then I'll put the dt in the numerator and RC in the denominator. Then equate it to 0. Then I have dV over V is equal to negative 1 over RC multiplied by dt. So I just transposed the negative 1 over RC dt. So integrating both sides, I'll have ln of V is equal to negative t over RC, because negative 1 over RC is just a constant, and I can have here integration constant ln of V sub 0 so that I can transpose it on the other side. So I will have ln of V minus ln of V sub 0 is equal to negative t over RC. And by loss of logarithm, we have ln of V all over V sub 0 is equal to negative t over RC. Okay, and to solve for V, we can have E in both sides of the equation to cancel the ln, and I will have V over V sub 0 is equal to E raised to negative t over RC. And simplifying, we can have V or V of t. Okay, and cross multiplication, I'll just have this formula equal to V sub 0 E raised to negative t over RC. So this is the formula for our source-free RC circuit. Now let us consider the voltage across the resistor initially. So if you have here a circuit and we have here a switch, okay, if we assume the battery has no internal resistance, the voltage across resistor will be the EMF. So if we have your supply E and the switch is turned on, so yung voltage drop natin kay resistor will be equal to the maximum or equal to our supply E. Okay, so sa graph natin, ito siya kasi yung voltage drop natin equal siya sa EMF. But since our resistor is in series with the capacitor, after a very long time, yung voltage drop natin kay capacitor is mag-i-equal na siya sa EMF. So yung voltage drop natin ngayon kay resistor is pababa na siya. So, the result, the potential difference between these 2 points will be 0. Therefore, there will be no voltage drop across resistor after the capacitor charges. So, this is while the capacitor is charging.
So, yung current, syempre, mula dun sa maximum na state niya, so yung E over R by Ohm's law, so bababa din yung ating current, papunta sa 0. So, yung voltage drop naman natin sa capacitor, so mula sa 0, since nag-charge nga siya, okay, so tataas siya ngayon, papunta dun sa EMF na value natin. So, as the capacitor charges, it eventually reaches the same voltage as the battery or the EMF in this case after a very long time. And it does not happen linearly. So, ito nga siya, yung graph niya is may curve, no? So, exponential kasi yung pagtaas ng voltage kay capacitor. And similarly, yung yung current kay capacitor, since naka-series yung resistor natin kay capacitor, so, bababa lang din, no? Mula sa maximum value niya, papunta sa 0. So, the graphs that we have just seen show us that this process depends on the time. Now, let's look at the units of both the resistance and the capacitance. So, yung unit for resistance natin, di ba, equal sa ohms. And equal yun sa volts over ampere by Ohm's law, no? Voltage divided by the current. Yung unit naman natin for capacitance is equal to farad or coulombs per volts. So, pag minultiply daw natin yung resistance sa capacitance, so volts over ohms times coulombs over volts, so makancel natin yung volts, magkakaroon tayo ng coulombs over ampere. But 1 ampere is equal to coulomb per second. So, sa substitute lang natin yung 1 ampere sa coulomb per second, makancel yung coulomb, yung matitira tayong seconds. Therefore, pag minultiply daw natin ng resistance kay capacitance, ang unit natin is seconds. Okay? So, ito yung tinatawag nating time constant, yung R multiplied by C, or denoted by this symbol, so tau. Okay? So it is clear that for a given value of C, for any value of R, it affects the time rate at which the capacitor charges or discharges. So yung product ng R and C natin is what we call now as the circuit capacitive time constant. Okay? So yan yung symbol, Greek letter tau for the time constant. So ano ba yung time constant? So, time constant is the time that it takes for the capacitor to reach 63% of the EMF value during charging. So, kapag ginraph daw natin yung pagtaas yung pag-charge ng capacitor natin, pag na-reach na yung 63%, that's equal to 1 RC. Okay? So, at this point, equal siya sa 1 RC. So, is there a function that will allow us to calculate the voltage at any given time t? So, kung meron tayo dito yung circuit, we can use KVL. So, kanina, di ba, dun sa source-free RC circuit na derive natin yung formula na VOE raised to negative T over RC. So, dito, pag meron na siyang R, so, di ba, initially equal siya sa E. So, yung V of T natin ngayon equal sa E minus E times 1 minus E raised to negative T over RC. And yung I of T natin, so, equal lang din sa I O times 1 minus e raised to negative t over RC. Okay? So, yun yung magiging formula natin. Oops. Ayan. So, paano ba nakuha yung 63% kanina? So, mula dun sa binigay na formula for the voltage, V of t. So, mula dito, pag kinuha natin at time t is equal to 1 over RC, so, substitute natin yung t is equal to 1 over RC dito sa formula. So, magiging negative RC over RC. So, ito magiging e raised to negative 1. At 1 minus e raised to negative 1 is equal to 0.63 e. So, kaya nakuha yung 63%. So, kapag yung time natin equal sa 1 RC, yung charge na nung capacitor natin is nasa 63% na nung voltage supply. Okay? Pag naman 2RC, so ayan, nasa 86% na siya. Pag 3RC, 95%. 4RC, 98%. Okay? So, dito sa graph natin, during 1RC, papuntang 3RC, 3RC to ha, sobra ng isa. 3RC, so yun daw yung transient state. So, andito yung pagbabagong nagaganap mula dun sa 1RC, mula sa 63%, tumataas yung voltage ng capacitor natin papunta sa 95%. Then, sa 4RC, hanggang sa mag fully charge. So, yun naman yung steady state. Okay? So, yung capacitor daw natin is considered fully charged after 4 to 5 time constants. Or kapag nandun na siya sa steady state. Bago niya ma-reach yung steady state, meron tayong transient state na tinatawag. So, next, so capacitor discharging resistor's voltage. Suppose now that the switch moves downward towards the other terminal. This prevents the original EMF source to be a part of the circuit. So, di ba kanina, nandun yung switch natin sa, nakakonect dun sa supply. So, paano naman daw kapag in-switch na natin dito, so connected siya sa ground, so wala nang source yung ating RC circuit dito. No? So, at time t is equal to 0, the resistor gets maximum voltage, but as the capacitor cannot keep its charge, the voltage drop decreases. So, ganun yung magiging state ng ating voltage drop kay resistor. So, yung charge ng ating capacitor, masusupply niya si resistor at max. Tapos, as time passes by ulit, so, syempre, magdi-decrease yung ating voltage drop kay resistor. Similar to its charging graph, yung current through the resistor must decrease as the voltage drop decreases due to the loss of the charge on the capacitor. Ayan, so bababa din syempre yung current kapag bumaba yung ating voltage. Now, the discharging graph for the capacitor is the same as that of the resistor. There will be a time delay due to the time constant of the circuit. So, mula dito sa voltage capacitor natin, ito. So, ito yung state kung saan fully charged yung ating capacitor, no? So, yung pagbaba niya, ganyan yung movement. So, marireach na yung at time t is equal to RC, marireach na yung 37% ng EMF. Okay? So, galing lang din naman siya dun sa formula kasi diba yung VC natin equal sa VO e raised to negative T over RC. So, pag yung T natin equal sa RC, pag sinubstitute dyan, so equal yan sa 0.37 ng V sub O. O kaya 37% to. So, similar to his charging graph, since nakasigis nga yung resistor natin kay capacitor, so syempre, bababa din yung current kay capacitor. And ito yung voltage na nung capacitor. Ito yung dinerive natin kanina. Yung E sub O natin or B sub O, so same lang naman yun. E raised to negative T over RC. So it is initial voltage yung B sub O natin. I sub O, ang I of T natin equals I sub O E raised to negative T over RC. So, the key to working with a source-free RC circuit is finding these two parameters. So, una natin yung initial voltage. V sub O natin is equal to V of 0 is equal to V sub O across the capacitor. And we need to find also the time constant tau or yung equal sa RC, no? So, let's have a sample problem. Let V sub C of 0 is equal to 15 volts. Find V sub C, P sub X, and I sub X for T is greater than 0. So, yung V sub C natin is yung voltage drop kay capacitor na 0.1 farad. At yung V sub X na hinahanap is yung na kay 12 ohms naman, no? So, para natin siya isosolve, lagyan natin siya dito. So, ano muna yung una natin gagawin? Kunin natin yung equivalent resistance para ma-solve natin yung RC kasi kailangan natin yung RC, no? So, di ba yung Yung tau kasi natin equal siya sa R equivalent times C. So, kailangan natin makuha yung R equivalent. So, ano yung R equivalent natin dito? So, di ba ito, yung 8 tsaka yung 12 natin is naka-series. Tapos, naka-parallel sila kay 5. So, this is 20 ohm. Tapos, naka-parallel sila kay 5 ohm. So, this will be equal to 20 times 5 over 20 plus 5. So, ang R equivalent natin equal sa 4 ohm. So, yung tau natin, or R equivalent times C, so that is 4 ohm times, ano yung ating capacitance, that is 0.1 farad. So, we have 0.4 seconds. Okay? So, sunod, anong makukuha natin, yung voltage kay capacitor, di ba sabi, ang formula natin kanina, yung formula natin kanina, V sub O e raised to negative t over tau or RC, no? So, yung V sub O na given is 15 volts. Then, e raised to negative t. Then, yung tau natin equal sa 0.4. So, this will be over 0.4. So, yung V sub C natin equal sa 15 e raised to negative 2.5 t volts. So, ayan siya. Since wala naman nang binigay na time, so, ganito lang yung magiging sagot natin. Naka-equation siya. Nakuha po ba? Hello? Nakuha po?
Yes po, ma'am.
Ayan. So, ano pa yung hinahanap? Hinahanap daw si V sub X. So, yung V sub X natin, siya yung voltage drop kay 12 ohm. So, para makuha natin to, ano yung kukonsider natin? So, kung mapapansin nyo, di ba yung capacitor natin is nakaparallel kay 8 and 12, di ba? At kapag parallel, same yung voltage, no? So, since same yung voltage kapag parallel, so ibig sabihin, yung voltage natin kay capacitor equal sa voltage nitong ng combination ng 8 and 12. So, pwede tayong gumamit ng voltage divider, no? Lagay natin by voltage divider. Yung V sub X natin ngayon equal sa, so ito yung 12. 12 over 12 plus 8 multiplied by yung VC natin na nasolve. 15 e raised to negative 2.5 t. So, Vx natin equals sa 12 over 20 times 15. Ito equal?
9.
9. Yan. So, 9 e raised to negative 2.5 t. And huwag nyo kalilimutan yung volts. Yan. So, ito yung V sub X natin. Tapos, yung isa pang hinahanap is yung I X. Okay, so ito, ano lang naman siya? Ohms law lang. So, Ix natin equal lang sa Vx over 12. So, 9 e raised to negative 2.5t all over 12. So, Ix natin equal sa 9 over 12 natin, 3/4 to, no? So, 0.75 e raised to negative 2.5t ampere. So, ganun siya. May tanong ba? Tanong?
Wala po, ma'am.
Okay. So next, calculate the voltage V of T and the energy stored in the capacitor. So, huwag natin siya dito. Hinahanap natin yung voltage V of T and the energy in the capacitor. So initially, at T is equal to 0, naka-on to, ay naka-papunta dito. So, open yung switch natin. But before that, i-consider muna natin yung at T is less than 0 or kapag hindi pa naka-on yung switch na to. Okay? Ito, nakikita nyo ba yung yung pointer ko? Ayan. So, at T is less than 0, kukunin natin yung initial value ng ating capacitor. Okay? So, Paano nga ba yung class, yung status ng ating capacitor kapag DC? Di ba kapag in-on natin to, so kapag nakakonect yung switch natin dito, nakakonect yung ating 20 volts sa circuit, no? So, yung capacitor natin dito, anong status kapag merong DC?
Close lang na po.
Close o open? Ano nga yun? Di ba meron tayong disco?
Open
Open, no? So, di ba yung sa disco natin, kapag DC, yung inductor natin is shorted, di ba? Tapos, yung capacitor naman natin, capacitor. Siya naman yung open. Okay? So, kapag naka-switch ito, ayan, naka-switch siya. So, connected yung 20 volts natin sa circuit, yung ating capacitor dito is naka-open. So, kung naka-open to, yung 1 ohm natin dito parang naka-hang lang siya, 'di ba? So, hindi na natin ko-consider itong 1 ohm. So, kukunin muna natin yung voltage kay 9 ohm kasi parallel siya dito kay capacitor, 'di ba? So, pwede natin sabihin na kung ano yung voltage kay 9 ohm, siya yung magiging initial na voltage ni capacitor. Okay? So, para makuha yung voltage kay 9 ohm, by ano lang tayo, voltage divider. So, at B sub C of T, gawin na natin ganun. 20 volts times 9 over 9 plus 3. Saan to equal?
15.
15 volts. So, ito ano lang tayo, voltage divider lang. Okay? Tapos, wag natin ulit yung tau. Tau natin is R equivalent times C. Ano yung magiging equivalent resistance natin dito? So, ito ano na ha. Since nakuha natin yung initial value ni capacitor, consider natin ngayon kapag naka-open na itong switch. Sigurahin natin to para di kayo malito. Oops. Ayan, so naka-open na yung switch. So naka-disconnect na ngayon yung ating circuit na nasa right side kay naka-disconnect na kay source, no? So i-consider naman natin itong right part, okay? So yung R equivalent dito sa right part na to is 9 plus 1. Okay? Ulit ko baka ayan, yung R equivalent natin is 9 plus 1. So that is 10 ohms times yung capacitance natin is 20 millifarad. So, saan equal ngayon yung tau natin? Move lang to, no? 0.2 seconds. Okay? So, meron na tayong tau, tapos meron na tayong initial na value ng ating, capacitor. So, yung V of t natin na hinahanap equal sa, ito equal din sa V sub O, ha? Ayan, V sub O or V sub C of t. V of t natin equals sa 15 volts e raised to negative t over 0.2 volts or V of t natin equals sa 15 e raised to negative 5t. So ito inakyat ko lang yung 0.2. 1 over 0.2 equals sa negative 5t volts. Ayan. So ayan yung V of t natin. Tapos isa pang hinahanap is yung energy. So ano nga ang formula for energy ng capacitor?
W equal 1/2 V,
C,
CV squared.
yeah, CV squared. Okay. So 1/2, tapos yung C natin is equal sa 20 millifarad. Then yung voltage natin is 15. Pwedeng ito na lang din, yung 15 volts, kasi yun naman yung initial na natin ng capacitor. So 15 volts na lang yung consider natin. So 1/2 times 20 millifarad times 15 squared. Saan to equal?
2.25.
So, 0.25, ano unit ng ating energy?
Joule.
Joules. Ayan, so ito siya. Pero kapag tinanong, energy at a time t, so syempre, consider nyo itong V of t, yung naka-e raised to negative 5t pa, no? Ayan. So, 2.25 joules. May tanong ba sa source-free RC circuit? Wala. So, proceed tayo kay source-free RL circuit. So, source-free RL circuit natin. So, ganun ulit. We have inductor and resistor. So, walang source. So, pag consider natin, by ano naman tayo ngayon, by voltage drop. By KVL, we have V sub L plus V sub R is equal to 0. So, saan equivalent yung V sub L natin? Saan equivalent? Diba, equal siya sa L di dt. No? Tapos yung voltage drop naman kay resistor by Ohm's law, that's equal to BR. By I no lang tayo pala. Ohm's law natin is RI. Equal sa 0. Tapos, itong L natin, ibaba na natin dito. So, di over dt plus r over L I equal to 0. I mean, may I pa pala doon. So, ibaba na rin natin yung I. Tapos, transpose na natin negative r over L dt. So, similar dun sa ginawa natin kanina, integrate natin both sides. So, sabihin natin pag in-integrate to, gawin ko na tong capital I. I of t. Hindi, I lang muna. Loan of I loan of I, ayan, equals sa negative R over L, T, plus yung integrating constant niya, loan of IO, initial value natin. So, lipat lang natin sa kabila, we will have loan of I minus loan of I sub O equals sa negative R over L, T. Tapos, by laws of logarithmic, we have loan of I over I sub O. So, this is equal to negative R over L T. Then, lagay tayo ng E both side para makancel yung loan. So, magkakaroon tayo ng I over I sub O equals to negative, E raised to negative R over L T. So, yung I of T natin pala equals siya sa I sub O E raised to negative R over L T. Ayan. So, ito naman yung consider natin current kapag source-free RL circuit. Okay? Ayan. So, this shows that the natural response of the RL circuit is an exponential decay of the initial current. It is evident from the above equation that the time constant for the RL circuit is L over R. Ayan. So, yung tau naman natin, ito siya. Ito siya, diba, na part. Ayan, kaya lang, diba, pag binaba natin to, diba, kasi negative T over tau kasi siya. So, yung tau natin equal sa L over R. Okay? So, the smaller the time constant of a circuit, the faster the rate of decay of the response. The larger the time constant, the slower the rate of decay of the response. So, at any rate, the response decays to less than 1% of its initial value. So, similar lang sa capacitor natin or sa RC circuit, it reaches the steady state after 5 tau or 5 time constant. So, the key to working with a source-free RL circuit is to find the initial current. I sub O is equal to I of 0 is equal to I sub O through the inductor. So, parang yung kanina lang, hinanap natin yung initial value ng capacitor. So, dito, initial value naman ng current. Okay? Yung sa inductor, yung kunin natin. Then, yung time constant tau of the circuit. Okay? Ayan. So, sample problem. The switch in the circuit below has been closed for a long time. At the switch is open, calculate for t is greater than 0. So, initially daw, yung circuit natin is naka-close. So, nakaganto siya. Okay? So, hanapin natin, kapag nag-open yung switch, kakalculate natin yung Nawala yung ano. Kakalculate natin yung I of t dito. 40 is greater than 0. So, consider muna natin yung initial na state. Pag naka-close itong switch natin, so anong state ng ating inductor?
Short.
Shorted. So, kung shorted to, kung shorted yung inductor natin, ano pa yung shorted dyan? Masya-short niya din si 16 ohm, diba? Kasi nakaparallel siya kay 16 ohm. So, yung current natin, na dadaan kay 4 ohms, hindi na siya dadaan kay 16 ohm. Kasi mas walang harang dito eh. Diba? Wire na lang to. Shorted to eh. So, dito na siya didiretso. Hindi na siya dadaan kay 16 ohm. So, 16 ohm, parang shorted na rin siya. Okay? Nagets po ba yun? So, consider natin yung resistance na matitira na lang itong 4 ohm is parang nakaparallel na lang kay 12. Okay? Lagyan natin. So, parang nakaparallel na lang. So, 4 times 12 over 4 plus 12. 48 over 16 is 3 ohm. So, pag kinuha natin yung total current na dumadalo, sabihin natin yung I total. So, I total natin, by Ohm's law, di ba ito, pinag-combine na natin, so mayroong 3 lang dyan. So, parang, naka-ano lang siya, naka-series na lang na ganito, no? So, ito yung 2, ito yung 3, tapos ito yung 40 volts. So, para makuha yung current, so by Ohm's law lang. So, 40 volts over 2 plus 3, or 5, so we have 8 ampere. Kuha po. Tapos, kunin natin yung initial na current na dadaloy dito kay inductor. So, syempre, since parang shorted nga itong ating 16 ohm dito, so yung dumadaloy kayo ngayon kay 4 ohm, so parang yun na rin yung initial current ng ating inductor. So, kukunin natin tong IO dito. So, yung IO natin is simply, saan siya equal? Pag nag-current divider tayo, current divider naman gagamitin. So, 8 ampere multiplied by ang kabila, no? 12 over 12 plus 4. Saan to equal? 8 times 12, 72. Ayan, 6 ampere. Okay, so meron tayong IO. So, sunod natin, balik na tayo dun since meron na tayong IO, balik na tayo dito sa pag-o-open itong switch. Ay, bumalik. Balik ba? Tumaas. Ayan. Balik natin ayan, naka-on na yung switch natin. So, ito, wala na yung pagkaka-short nila. So, source-free RL circuit na tayo. So, ano na yung equivalent na resistance natin? So, ito, naka-open. So, yung 4 natin tsaka 12, parang naka-series, di ba? Tapos, naka-parallel sila kay 16. Tama ba? So, yung R equivalent natin, we have 4 or 12 plus 4 na naka-parallel ngayon kay 16. No? So, ito ay 16 parallel kay 16. So, yan ay 8, no? Kasi half lang. Tapos, meron na tayong R equivalent, pwede na tayong mag-proceed sa pag-solve ng tau. So, yung tau natin ay L over R or L over REQ. 2 over 8. Okay? 2 Henry over 8 ohm. So, this is 1/4 second or lagyan natin 0.25 seconds. So, pag sinolve natin yung I of t, so, diba yung formula nun I sub O e raised negative t over tau. So, equal siya sa yung IO na na-solve natin, 6 ampere e raised to negative t over 0.25 or 6 e raised to negative 4t ampere. I of t. So, ayan. Ayan yung ating current. Nagets po ba? Nakuha po ba?
Yes po, ma'am.
Ito yung circuit natin. Ito. So, hinanap natin yung I.O. Ito siya. So, yung I.O., yung V sub O, tsaka yung I na dumadali kay inductor. Okay? So, sabi, yung switch daw was open for a long time. So, yung initial condition niya is naka-open muna to. Itong switch natin, no? So, kung naka-open yan, yung circuit natin is connected kay 10 volts, diba? Pag naka-open, so parang wala tong switch. So, ganun na lahat. Yung inductor natin is shorted. Tapos, since naka-parallel yung 6 ohm sa kanya, so ito parang shorted din, diba? So, i-consider nating resistor is yung 2 ohms lang, tsaka yung 3 ohms. So, kapag sinolve natin yung current na madaloy dito, I.O., so diba shorted naman to, tapos parang series na yung mangyayari dito sa 2 and 3. So, yung I natin is equal to 10 volts over 2 plus 3 or equal sa 2 ampere. Okay? So, yung V sub O natin, since may current na dumadalo na sa kanya, yung V sub O natin is just ohms law lang. So, 3 ohm multiplied lang by 2 ampere. So, that is equal to 6 volts. No? So, ngayon, i-close natin yung switch. Pag kinlose natin yung switch, so, source free RL na siya kasi shorted ngayon yung ating supply, 'di ba? Pag ito naka-close, so ito masho-short niya yung supply natin. Kaya parang source free RL circuit na siya, no? So, i-consider natin ngayon na mga resistance itong 3 ohm tsaka 6 ohm na nakaparallel, 'di ba? Kung wire ito, so yung 3 ohm natin nakaparallel lang kay 6 ohm. So, for T greater than 0, yung 10 volts natin is naka-short na. So, yung R equivalent natin equal lang sa 3 nakaparallel kay 6 or 3 times 6 over 3 plus 6 equal sa 2 ohm. Tama? 18 over 9 no? 2 ohms. Tapos, solve natin ngayon yung time constant. So, L over R EQ equal sa, ano yung L natin? 2 Henry over 2 ohms. So, that is equal to 1 second. Okay? So, yung I of T natin ngayon equal sa I-O e raised to negative T over tau. Ano yung I-O natin? 2. 2 e raised to negative T over ay 1 second din pala. So, 2 e raised to negative T ampere. Okay? May tanong ba? So, pag gusto natin i-solve, kunyari yung voltage ngayon kay inductor, di ba yung formula para sa voltage ng inductor ay equal sa L di dt. No? So, yung L natin is 2 Henry. Tapos, yung current ng inductor is 2 e raised to negative t, di ba? So, d of 2 e raised to negative t with respect to time t. So, derivative lang natin itong 2 e raised to negative t. Saan ba derivative nito? Ano derivative nito? Equal lang sa negative 2 e raised to negative t, no? Kasi diba same lang naman sila? Yun nga lang may negative sa taas. So, kaya may negative dito. So, yung V sub L natin yun equals sa negative 4 e raised to negative t volts. Okay? Nakuha po ba? Tapos, yung I sub O natin, pag kinompute natin, itong current na dumadaloy kay 6 ohm. So, I sub O natin, since itong 6 ohm natin is nakaparallel kay inductor, ibig sabihin, same sila ng voltage, no? So, kung same sila ng voltage, yung VL natin, pwede natin, ay yung voltage drop dito kay 6 ohm, similar kay voltage ng inductor, so pwede natin gawin na VL over 6 ohm lang siya. So, VL natin is negative 4 e raised to negative t over 6. So, this will be negative 2 over 3 e raised to negative t ampere. Nagets po ba? May tanong ba sa source-free RL and RC circuit class? So, basta yung pattern lang ng pagsosolve, no? So, i-consider nyo muna yung initial condition ng circuit natin. So, bago siya makikita nyo naman dun sa arrow So, kung saan siya papunta. So, bago nyo i-consider yung direction ng arrow, consider nyo muna yung t less than 0, so yung initial condition niya. Okay? Bago kayo mag-solve nung tau, tsaka nung papunta dun sa I of t, tsaka dun sa b of t kapag naman RC. Okay? So, ayan siya. So, wala nang tanong, proceed tayo kay singularity functions. So, singularity functions, also called switching functions, are very useful in circuit analysis. They serve as good approximations to the switching signals that arise in circuits with switching operations. They are helpful in the neat, compact description of some circuit phenomena, especially the step response of RC or RL circuits, to be discussed in the next section. So by definition, in singularity functions are functions that either discontinuous or have discontinuous derivatives. Three most widely used singularity functions are unit step, unit impulse, and unit ramp function. So, identify natin yung tatlong yan. Start tayo kay unit step function. So, unit step function natin, u of t is 0 for negative values of t and 1 for positive values of t. So, kaya nga siya unit step. So, ganito lang yung graph niya. So, 0 yung value niya sa negative. 0 yung value ng u of t kapag negative values of t. Tapos, 1 naman siya pag sa positive values. Ayan. So, in mathematical terms, ganito yung representation niya. 0 for t is less than 0. 1 for t greater than 0. So, unit step function is undefined where it changes abruptly from 0 to 1. It is dimensionless. Wala siyang unit. Like other mathematical functions such as sine and cosine. Then, if the abrupt change occurs at t is equal to t sub 0, where t sub 0 is greater than 0 instead of the unit step function, it becomes u of t minus t sub 0. Yan. Kung meron daw tayong involved na t sub 0 ngayon, pag nasa, pag greater than 0 siya, so parang delay, okay? Delay yung u of t natin ng by t of 0. T sub 0 seconds, okay? So, yung function natin is u of t minus t0. Okay, ito siya. So, 0 for t is less than t sub 0 and 1 is 1 naman yung value niya pag t is greater than t sub 0. So, delay yung signal natin by t sub 0. Tapos, kapag naman nagbago yung function natin at t is equal to negative t sub 0, so, ibig sabihin, yung unit step function natin is advanced naman. So, nauna siya. Nandito siya sa part na to. Okay? Tapos, nandito yung negative t sub 0 natin. Okay? We use the step function to represent the abrupt change in voltage or current like the changes that occur in the circuits of control systems and digital computers. So, for example, the voltage V of t is equal to 0 for t is less than t sub 0 and V sub 0 for t is greater than t sub 0. So, yung unit step function daw, yung yung application niya. So, ginagamit siya sa mga circuits of control systems and digital computers. So, yung lang, parang on-off lang yung yung output, no? So, kapag less than t sub 0, 0 lang yung value ng voltage doon. Pag naman t is equal to, or t is greater than t sub 0, so, mag-equal naman siya sa v sub 0. This may be expressed in terms of the unit step function, v of t is equal to v sub 0, u of t minus t sub 0. If we let t sub 0 is equal to 0, then v of t is simply the step voltage, v sub 0, u of t. Kung wala siyang delay or advance, so ito lang yung function niya. And so ito yung pag kinuha natin yung equivalent circuit, pag in-apply natin yung step function sa circuit, so meron tayong voltage source v sub 0 u of t. So at time t less than 0, so 0 pa lang siya. So, parang connected siya kay ground, no? Tapos, kapag t greater than 0 naman na siya, so magsiswitch na siya dito. So, equal na siya sa v sub 0. So, ganun lang yung unit step function. Similar naman din sa pag-current source yung circuit natin. So, at t is less than 0, connected pa siya sa ground, so I is equal to 0. Tapos, pag nag-switch na siya sa t is greater than 0, so meron na tayong current na mababasa ngayon. Now, yung derivative ng unit step function is the unit impulse function, delta of t, which we write as, delta of t is equal to the derivative of u of t with respect to time t. So, yung function niya, 0 siya, okay? 0 siya for t is less than 0. 0 din siya for t greater than 0. And for t is equal to 0, undefined yung value niya. Or, dito, nilagay siya as infinite. Okay? So, isang lang siya, isang pataas na arrow lang yung nire-represent ng natin, ng delta of t, or yung unit impulse function, also known as the delta function. So, it is delta. Delta yung, symbol. So, unit impulse function delta of t is 0 everywhere except at t is equal to 0 where it is undefined. Pero kapag may binigay na value, so, syempre, magkakaroon tayo ng magnitude dito sa unit impulse natin. Impulsive currents and voltages occur in electric circuits as a result of switching operations or impulsive sources. So, dun siya nag-occur. Unit impulse may be regarded as an applied or resulting shock. It may be visualized as a very short duration pulse of unit area. This may be expressed mathematically as the integral of the delta of t dt, so equal to 1, where t is equal to 0 negative denotes the time just before t is equal to 0, and yung t is equal to 0 plus naman, the time just after t is equal to 0. So, parang yung kanina lang, pag kino-consider natin yung at t is less than to 0, so parang equivalent niya lang dito sa impulse is yung t is equal to 0 negative. Pag naman, yung isa, t greater than 0, so siya naman yung t is equal to 0 positive. The unit area known as the strength of the impulse function. When an impulse function has a strength other than unity, the area of the impulse is equal to its strength. So when a function is integrated with the impulse function, we obtain the value of the function at the point where the impulse occurs. This is highly useful property of the impulse function known as the sampling or shifting property. So, ito yung example ng natin, impulse function. So, meron tayo dito 3 impulse functions. So, ito, 5 delta of t plus 2. Mapapansin nyo, yung t plus 2 siya kasi naka-delay siya ng t is equal to negative 2. No? Delay siya. Advance siya ng 2 seconds dito. So, t plus 2 to. Tapos, yung value niya is 5. Kunyari, ito 5, tapos ito 10. So, dito naman, 10 delta of t. So, at 0, delta of t lang siya. Pag naman siya pababa, okay, pag pababa, yung arrow niya, so, mapapansin niyo may negative dito. So, kasi nandito, sabihin na, hindi pinakita, so, siguro ito yung negative 4 to. Delta of t minus 3. Kasi may delay siyang 3. Okay? So, ganun yung kapag meron tayong makitang mga arrows lang, kung paano natin siya ininame. Okay? So, kapag ganyan, pag nandito siya sa left side, so naka-plus ito, ha? Pag naman dito sa right side, so naka-negative naman yung ating kasama sa time. Integrating the unit step function results in a unit ramp function. So, kung yung step function natin, pag dinerivative, ang lalabas ay impulse. Kapag naman in-integrate natin yung unit step function, ang lalabas naman ay ramp function or r of t. So, ganito yung itsura naman niya. The unit ramp function is 0 for negative values of t and has a unit slope for positive values of t. So, yan yung itsura niya. Unit ramp function. So, pag in-integrate daw yung unit step function, lalabas ay unit ramp function. Yeah. So, nilagay lang siya dito. So, yun yung relationship ng impulse, step, and ng ramp. So, yung impulse natin is a derivative of the step. U of t natin is the derivative naman ng derivative ng ramp naman natin is yung step. Yan. Pag integrate, ayan yung kabaliktaran naman nila. So, the unit ramp function may be delayed or advanced as shown below. So, kapareho lang din ng class ng unit step function. So, pwede siyang delay or advance. So, maglalagay lang tayo ng t minus t sub 0 kapag advance. Tapos, kapag delay. Tapos, pag advance naman, t plus t0. Okay, so, ganun lang din siya. Express the voltage pulse in terms of the unit step. Calculate its derivative and sketch. So, paano natin to lilabelan? So, ito, di ba, nasa 2 siya. So, anong magiging function na to? Pagpataas siyang ganito. No? Tapos ito, pababa siya dito. Tapos ito na kay 5. So, ano to? Advance or delay?
Advance po. Kasi nasa first region.
Delay.
Delay siya kasi na-delay siya ng 2 seconds. Di ba parang, isipin nyo na lang, yung normal signal, dapat magsa-start na siya at 0, at time t is equal to 0. Pero, hindi pa siya nag-start agad. Nag-start siya at 2 seconds. So, ibig sabihin, na-delay yung ating signal by 2 seconds. Okay?
Pag first quadrant po ba, magde-delay siya, hindi po siya advance.
Yung sabi natin kanina, kung nandito siya sa negative side, 'di ba? Doon siya naka-advance, no? Negative 1, negative 2. Kunyari, nandito siya. So, imbes na normally, at time t is equal to 0 yung signal natin, kung nauna siya, kung nandito pa lang sa negative values, meron na siya. So, ibig sabihin, nag-advance siya dito. 'Di ba? Pero kapag nandito yung signal natin sa right side, so, kunyari, nag-expect ka na dadating yung signal t is equal to 0, hindi dumating. So, ibig sabihin, delay dito sa right side. Nakuha po ba? So, kapag kunyari, yung signal nyo, dumating pa lang ng t is equal to 2 seconds. So, may delay na 2 seconds, diba? Okay. So, yung v of t natin dito, yung magnitude natin is 10. Okay? 10. U of t minus 2. Kasi nasa 2 siya. So, delay siya ng 2 second. Tapos, pababa siya ng t minus 5. So, kaya may negative dito. T minus 5. Okay. So, pag finactor lang yung 10, we have u at 10 times u of t minus 2 minus u of t minus 5. Tapos, pag dinerivative daw siya, or in-express natin siya dun sa impulse function. So, ganun lang yung itsura niya. 10 of delta of t minus 2 minus delta of t minus 5. So, yung itsura nung impulse function natin is ganito. So, di ba yung sabi ko nga kanina, ano lang siya, isang arrow lang ang ating impulse, no? Yan. So, at t is equal to 2, so, nandito yung 10, so positive. Tapos, kapag t is equal to 5 naman, dito siya pababa kasi negative. Okay? So, ito, express the current pulse in terms of the unit step, calculate its derivative, and sketch it. So, meron tayo ditong nag-start sa 0. So, ito, di ba, pataas. Tapos, pababa siya dito. Parang hindi siya tumigil sa 0. Mababa siya dito sa negative 10 pa. Tapos, ito, paataas na naman. So, dito, anong function to? Ito, ano lang, 10u of t lang, no? Kasi nasa 0 siya. Tapos, bumaba siya. Ito ay 10. Tapos, may 10 pa dito. So, sabihin natin, ito ay negative 20. U of, ano to? T minus 2, no? Tapos, umakyat ulit siya dito. Tapos, yung magnitude niya is 10 lang naman. So, 10 U of t minus 4. Okay? Tapos, yan, pagkasama-samahin nyo lang. So, yung 10 U of t minus 20 U of t minus 2 plus 10 U of t minus 4. Tapos, kapag kinuha daw yung, ano niya, yung ramp function niya, ito naman. yung magiging itsura. So, nilagay na rin kasi niya dito. 10 r of t minus 2 r of t minus 2. So, at t is equal to 2 seconds, so 20 siya. No? 20 yung value niya. So, 0 naman kapag t is equal to 0 din. Then, 0 ulit siya kapag t is equal to 4. So, i-apply naman natin ngayon yung itong singularity function, i-apply naman natin siya sa RC tsaka RL circuit. So, punta tayo kay step response of an RC circuit. So, when the DC source of an RC circuit is suddenly applied, the voltage or current source can be modeled as a step function, and the response is known as a step response. So the step response of a circuit is its behavior when the excitation is the step function, which may be a voltage or a current source. The step response is the response of the circuit due to a sudden application of a DC voltage or current source. Ayan. So yung tatawag natin step response. Kapag meron tayong sudden application ng DC voltage or current source. So, meron tayo ditong tinatawag na complete response ng RC circuit kapag nagkaroon tayo ng sudden application ng DC voltage, assuming the capacitor is initially charged. So, yung complete response natin is equal to the natural response or the stored energy plus the forced response. So, yung V of t natin, so at t is less than 0, equal siya sa V sub 0 or dun sa supply mismo. So, yung kapag greater than 0 naman, so ito yung complete response, V sub S plus V sub O minus V sub S e raised to negative t over tau. Okay? Or, ayan, kapag in-raf, so ayan, natural response plus forced response. So, yun yung total, natin, voltage. Or pwede rin nating sabihin na transient response yun, yung temporary part. Tapos, steady state response naman yung isa, permanent part. So, ganun lang din naman yung formula. V is equal to yung transient response niya plus the steady state response, VSS. Or yung V of t natin is equal to V sub O minus V sub S e raised to negative t over tau. Yung VSS natin is equal to VS or yung source, no? Source to, tapos V sub O to. Okay. So, transient response, V of t is temporary. It is the portion of the complete response that decays to 0 as time approaches infinity. Thus, the transient response is circuit's temporary response that will die out with time. Yung steady state response naman is the portion of the complete response that remains after the transient response has died out. Thus, the steady state response is the behavior of the circuit a long time after an external excitation is applied. So, ito yung pinaka-general formula natin. We have V of t is equal to V of infinite. So, ito yung Vs natin. Vs natin. Diba dun sa circuit, Vs to. Or yung supply. Where V sub 0 is the initial voltage at t is equal to 0 positive, and V of infinite is the final or steady state value. Thus, to find the step response of an RC circuit requires three things. Ayan, so consider natin, hanapin muna natin yung initial capacitor voltage, then yung final capacitor voltage, the V of infinite, and the time constant, tau. Wait lang, ha. Ayan. So, let's have a sample problem. The switch in the circuit below has been in position A for a long time. At time t is equal to 0, the switch moves to B. Determine B of t for t is greater than 0 and calculate its value at t is equal to 1 second and 4 seconds. So, meron tayo ditong point A and B. So, sabi, initially daw, yung switch natin is nasa position A for a long time. Tapos, at time t is equal to 0, ayan, move natin papunta sa B. So, parang magkakaroon tayo ng source-free RC circuit kapag minove na natin siya papunta kay B, no? So, ganun ulit, solve natin siya. T is less than 0. So, T less than 0. So, ano yung una natin sa solve? Yung initial voltage ng capacitor natin, no? Since ito, pag naka-switch siya kay A, 'di ba, naka-connect siya kay kay 24 volts. So ito parang open. Ngayon, yung condition niya, 'di ba? Kasi naka-connect siya kay 24 volts. So para makuha natin yung initial value ni capacitor, ang kailangan lang natin is yung initial voltage drop kay 5 kilo ohm, no? Kasi naka-parallel naman sila eh. 'Di ba kapag parallel, same yung voltage. So yung V sub O natin ngayon equal sa 24 volts may voltage divider lang multiplied by 5 kilo ohm over 3 kilo ohm plus 5 kilo ohm equal sa, saan to equal? (24 times 5 over 8, 15 volts, no? Ayan, so ito yung initial value ng ating capacitor. Now, i-move natin ngayon kay B yung ating switch. So, ayan, since meron na tayong 15 volts kay voltage ng capacitor, pwede natin consider tong kabilang circuit, no? So, for T is greater than 0, so meron lang tayong isang resistor. Req natin, 4 kilo ohm lang. So, yung tawag natin dyan, so Req times C. So, 4 kilo times 0.5 millifarad. Lumiko eh. 0.5 millifarad, so kilo. Plus milli magka-cancel. So, 4 times 0.5 equal lang sa 2 seconds. So, dito sa source-free RC circuit natin, 'di ba yung V infinite natin equal din sa yung V source, no? Eh ang source natin dito, 'di ba, si 30 volts. So 30 volts na siya. So yung complete nating response, V of t equals sa V infinite plus V of 0 minus V of infinite times e raised to negative t over tau. So V of t natin equals sa, yung V infinite is 30 plus yung b sub 0 na compute natin is 15 minus 30 e raised to negative t over 2. So, yung v of t natin ngayon equals sa 30 minus 15 e raised to negative 0.5 t volts. Okay? Tapos, hinahanap ngayon, ano daw yung value ng v of t natin at t is equal to 1 and at t is equal to 4 seconds. So, substitute lang tayo ng value ng time. So, at t is equal to 1 seconds, v of t natin equals sa 30 minus 15 e raised to negative 0.5 times 1. Ano magiging value nito? Ano magiging value? Tapos sa t is equal to 4 seconds, ganun lang din. So, substitute lang natin.
20.90 po.
20.90 volts. Ito, itong at 4 seconds naman,
27.97 po.
27.97 volts. Ayan. So, ayun yung values ng V of t natin kapag time is equal to 1 second tsaka 4 seconds. Nakuha po ba? May tanong ba? Okay naman? So, paano naman kapag RL circuit? So, ito naman yung complete response ng RL circuit natin. So, kamukha lang din nung nasa RC circuit kanina. Yun nga lang in terms of current tayo, no? So, yung I of t natin equals sa I of infinite plus I of 0 minus I of infinite times e raised negative t over tau. Thus, to find the step response of an RL circuit, it requires three things. First one, yung initial inductor current ulit, yung I of 0 at t is equal to 0. Tapos, yung final inductor current at I of infinite. Then, yung time constant. Okay? Yan. So, example, find I of t in the circuit below 4t is greater than 0, assuming that the switch has been closed for a long time. Okay? So, ay, dito tayo sa kabila. Ay, wala. Dito na natin isa-solve. Pagkasyahin natin. So, at t is less than 0, sabi, yung switch daw has been closed for a long time. So, naka-close muna ito, no? So, kung naka-close yan, shorted si 3 ohm natin, shorted, no? Tapos, shorted din si di ba? Si 1/3 Henry natin kasi nakakonect siya kay 10 volts, di ba? So, ibig sabihin, yung initial na current natin yan, si I of 0, ay equal lang siya sa 10 volts over 2 ohm or 5 ampere. Nakuha po? Ngayon, open natin yung switch. Open natin yung switch. So, ito naka-open. So, babalik natin sa 3 ohm. So, babalik natin si 3 ohm ngayon. At t is greater than 0. So, yung I at infinite natin, consider na natin kasama si 3. So, 10 over 2 plus 3 equals sa 2 ampere. No? And yung R equivalent natin, 2 plus 3 lang sila. So, 2 plus 3 is 5 ohm. Then, yung time constant, tau is L over Req. L natin, 1/3. Over, R equivalent natin ay 5. So, we have 1 over 15 seconds. So, kunin lang natin I of t. Formula kanina, I of infinite plus I of 0 minus I of infinite multiplied by e raised to negative t over tau. So, I infinite natin, 2. 2 plus I of 0 natin is 5 minus 2. So, this will be e raised to negative t over 1 over 15. So, this will be 2 plus 3 e raised to negative 15t. So, yun. Inakit ko lang kasi 1 over 15 naman to. So, this is our I of t. At huwag kalilimutan ang ampere. Okay? Ayun, so ganun lang siya. So, consider nyo lang yung at time t is equal less than 0, tapos after nun, at time t is greater than 0 naman.